We had talked about counting methods where the order matters, and that got us to the concept of permutations. Well, what if the order doesn't matter? How many ways can I choose a committee of 3 different people from a group of 9? So the order is irrelevant. You don't care which person was chosen first or second or third. And so to try to understand the next tool that we're going to use, when we've got president and vice president and treasurer, right, we said that there were this many ways to choose it. So it was 9 factorial over 9 minus 3 factorial. But if I were to make a little table here, in this situation, the number or the order in which I write things is important. And so if I write them as PVT, that means the first person was chosen as president, the second is vice president, the third person is treasurer. But when you have a committee of 3, it doesn't really matter. Now, it would have been different had you chosen things in a different way, right? So for example, I could have written PTV. That is a different group because the treasurer and the vice president are different people. I could have chosen VPT. I could have chosen VTP. Or I could have chosen TPV or TVP. So the same 3 people can make 6 different orders. So if we don't care about the orders, then we have to somehow eliminate all of these things. We are going to divide the number of total ways by the number of these orderings. So if you have a group of 3 people, there are 6 different orderings. And you could think of that as there are 3 people to choose in the first slot. Once you've chosen one of them, there are 2 people to choose for the next slot. And then once you've chosen them, there's only 1 person left. So it turns out the number of orderings is 3 factorial. So the number of ways to form a committee in this particular example is going to be that 9 factorial over 9 minus 3 factorial. That's what we had from before where the order mattered. Then we would divide by 3 factorial here to get rid of all of those extra possibilities. It will turn out to give us 9 factorial, 9 minus 3 factorial over 3 factorial. Now what we'll have is 9 factorial over 6 factorial times 3 factorial. That's going to end up giving us 504 divided by 6, which is going to be 84 ways. So we define this new symbol. So we would say this is called a combination. And in this example, the combination, we're going to use this same symbol, K choose N. We're going to take that permutation that we had before and then just divide by the number of orderings in the size of the group. So this permutation is going to be n factorial, combinations n factorial over n minus k factorial divided by another k factorial. So very scarily and generally, it kind of looks like this. But this is the number of ways to choose k objects from n total where the order doesn't matter. What's the probability of getting all spades in a poker hand? And because this is a classical definition, it's going to end up being the number of ways to get spades, all spades, in 5 cards divided by the number of ways to get a 5-card hand. The order is unimportant. I don't care whether I got an ace of spades first or an ace of spades last. It's irrelevant to me. As long as at the end of my 5 cards I have 5 spades, I'm in business. And so it will turn out that this probability says, okay, what's the number, all the different ways you can get 5 spade hands, 5 cards of spades in your hand. So these are the desirable outcomes. So this is going to turn out to be 5 out of the 13 spade cards you could have. And what's the number of ways to get different 5-card hands? Again, where the order doesn't matter. Well, you want to choose 5, but there are 52 for you to choose from. So these numbers are really, really big. These are gigantic. You're going to have 13 factorial over 13 minus 5 factorial, 5 factorial. 52 factorial over 52 minus 5 factorial, 5 factorial. Try to clean this up a little bit. I'm going to notice that these 5 factorials go away. And I could basically write this as 13 factorial over 8 factorial, 47 factorial over 52 factorial. If I were to clean this up, there's going to be a lot of stuff that cancels out with each of these. This is going to give me 9 times 10 times 11 times 12 times 13. This one is going to give me on the bottom 48 times 49 times 50 times 51 times 52. And that's going to end up giving me a really small number, about 0.0004,952. So it's a very, very, very small chance that I'm going to get all spades in my hand. It's teeny tiny. So I didn't need to directly list all the ways that I could do this. I just needed to be able to count them.